Okay, good morning, class. Hope you had a great weekend. I sent out a review for the exam. I sent that out last week, October 21st. When was that? Last Thursday. Okay, so I sent this out on Thursday. Check your email. You should have this. My intention, your test is on Thursday. So my intention here was to just go through the review. Does that sound like something useful? Would you all like for me to do that and not do anything new today?
Yes.
I got one thumbs up. Okay, yes. Okay, so that's what I'm gonna do. I'm just gonna work through the review. And when we're done, if there are any other questions, we'll answer the questions. And if not, we'll call it a day. I know Desiree will talk at the end, okay? All right, well, let's get started. I'm just going to go one by one through. There's only 7 questions here, and some of these take some time. So I'm going to try and take my time. Please ask questions if you have them. Now's the time. Also, please make note that you are allowed to have a reference sheet for this test. So when I say reference sheet, I mean one standard 8.5 by 11-inch sheet of paper, front and back, okay? Just make sure that that sheet does not have worked out problems on it. So the idea is not that you just take the review and put all the review questions and answers on your reference sheet. You can't have that. You can have steps, procedures, anything else, but nothing worked out. Is that clear? That'll be turned in with your work. You'll have to show that to the camera before the test starts. So just make sure you don't have anything that will cause a problem. I'm just trying to make sure it's fair for everyone. All right, let's crank this out. So on the review, I actually told you what each of these functions were, and that was supposed to help you to remember what technique we used in class to do these. On the exam, I will not tell you what they are. So you're going to have to be able to look at them and recognize what you're trying to graph. I think it's obvious. Do y'all think it's obvious that these are polynomials, these are rationals, and these are exponentials? They have distinctive characteristics to them. So, all right, let's do this first polynomial. So who can tell me the first step to sketch a polynomial?
Would you distribute and take out common factors?
That is a step. That'll be the second step I do.
Finding
When I find the x-intercepts.
coefficient.
Leading coefficient test. That's the first step. So what we're trying to do in the first step is determine what the left and right hand sides of the polynomial do. That's the first thing. So if I were making a reference sheet, I would make sure I have that step, right? So the first step, I'm going to do the leading coefficient test. That's what we called it. So I need to find the degree of the polynomial. What's the degree?
4.
4, highest power of x, right? 4. And then the leading coefficient is the number in front of that.
Is 1.
Is 1. Okay, then you have to go to a table that I had done in class where you have these 4 possibilities. I'm not going to bring that table back up. I'm going to trust that you can go to your notes and find that. But this, from the table, we should know here that the left side will go up and the right side will go up. And in the middle, we don't know. That's the first thing. The second step on this process are to find your x-intercepts. And to do that, this is the part, Emily, where you will take the equation, or you'll take the function, I should say. You will set it equal to 0, and you will try and solve this. So to solve that, I would first pull a greatest common factor out. That's what Emily suggested. When you pull that greatest common factor out, right, they all have an x squared. We have something left in here. So we pulled 2 x's away from this one, so we have x squared here. We pulled 2 x's out of this one, so we have an x. And we pulled both of these x's out of here, so we have the minus 20. So that's where we are. And now what I need to do is figure out, can I break this down further? can I take x squared minus x minus 20 and factor it further? So this is a trinomial. We talked about this throughout the semester, how to do this. You look at the number in front and the number in the back, and you multiply those, you get negative 20. And then you look at the number in front of x, which is negative 1. And you have to come up with two numbers that multiply to be this and add up to be this. Does anyone know what two numbers multiply to be negative 20 and add up to be negative 1?
Negative 5 and 4.
Negative 5 and 4. Good. And so what that tells me is that this would factor into two factors. It'll be x minus the 5, or x minus 5 and x plus 4, using those two numbers here. Good, good. All right, so here we go. We have x squared, then we have this becomes x minus 5, then this becomes x plus 4, and then equals 0. Now we have completely factored it. And so now what I do is I set each factor equal to 0. And then I solve each of these equations. So in the first equation, the only number that I can ever square and get 0 is 0 itself. Here I add 5 to both sides. I just get x is 5. And here I subtract 4 on both sides and I get x is negative 4. Questions? What's next?
Figuring out if it crosses or bounces.
Yeah, we have to figure out, these are our x-intercepts, right? These are dots on our x-axis. We want to know if our graph is going to cross through at those points or bounce. So what do I look at to determine that, bouncing or crossing?
The multiplicity of the factors.
Of the factors, exactly. You said that perfectly. So what we do is we look at the factors up here. I have this factor, I have this factor, I have this factor. I have 3 factors, and I look at the powers on each of the factors. This one had x squared. This factor, even though it's not written, we understand that there's a 1 here and there's a 1 on this one. We look at those numbers and we determine if they're even or odd. If they're even, what happens at that x-intercept?
It bounces.
Yeah, it's even here, right? Because 2 is an even number. And that tells us we're going to bounce here. This is odd, so we're going to cross. And this one is odd also, so we're going to cross. And that's pretty much all you need to be able to graph this. So now we go and we draw our picture. And it doesn't have to be perfect. Just you want to get a general idea of what's happening here. I'm going to start by plotting my x-intercepts. I have 1 at 0. I have 1 at negative 4. And I have 1 at 5. The next thing I'm going to use is this part right here that tells me that both sides go up. So I know on the left side this has to go up. And I know on the right side, it has to go up also. And now what I'm going to do is continue drawing this and make sure that when I get to my x-intercepts, I do what I'm supposed to do. So at negative 4, I'm supposed to cross through. So I'm just going to draw this. I'm going to cross through the x-axis. Then I've got to come back up here to 0. And when I get to 0, I'm going to bounce off the x-axis. And then continue through to 5. And when I get to 5, cross through, and then just connect it to this end. That's it. I explained to everyone in class that every person is going to have a slightly different picture, right? Someone might have something that looks like this, right? And that would be correct also, right? So there will be variation, but everyone should have the same x-intercepts. Our end behavior should be the same. And we should be like below the x-axis at the same places and above the x-axis in the same places. As long as that happens, we're good. Questions? All right, next one. Same thing, right? Polynomial. So let's do the first step. First step is leading coefficient test. So the degree of this one is 5, right? Highest power of x. And then the leading coefficient is the number in front, which is 1. And if you go look at your table, this is left side down, right side up. Middle is a question. Second step, x-intercepts. We set this equal to 0. We can do a GCF again, right? They both have 3 factors of x. So I can pull an x cubed out. And that should leave me 2 x's here. All the x's went away here, so I have -9 equals 0. And then I'm expecting that everyone will recognize this x squared minus 9 as a difference of squares. So x cubed, then this should become x plus 3, x minus 3 equals 0. And then you set each of these factors to 0. So I'm not going to show that. I'm just going to give you the 3 answers. And then we figure out if we cross our bounds. So when I look at the powers here, 3, something and something, since there's nothing there, that's a 1, that's a 1. Wait, they're all odd, right? All of them are odd. And since they're all odd, we're going to cross at each one of them. C, 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 cross, cross, cross. And then a picture. So got an x-intercept at 0, at 3, and at -3. Left side goes down, right side goes up. And then I just connect them all together and I cross through all the x-intercepts. So cross through. I just went way down there just for fun. Doesn't matter how far down I went, right? So when you draw your pictures, right, just make sure that with the polynomial function, it has to be smooth and continuous, meaning your graph shouldn't be jaggedy, shouldn't have any corners. Everything should be smooth and curved, right? You should not have any breaks in your graph. It's kind of what I got there. That's it. Good. So polynomials, to do the polynomials, you're going to need to be able to factor. That's probably the key part of the problem, is the factoring. Because if this gets messed up, everything's going to be wrong, right? So make sure that you know how to do a GCF and make sure that you know how to do a difference of squares. And on the previous problem, previous one, where is it? Oh, oops, hold on. Let me move this. I accidentally did this in the wrong place. Okay, here we go. So here, in the first one we did, we had to do a GCF, and then we had to factor trinomial using this method. Make sure you know how to do that, and then also GCF along with difference of squares. Those are kind of the 3 main things I want you to be able to do: GCF, trinomial, and difference of squares. All right, next one. So now we're moving on to rational functions, and this is a much more involved process, right? There's a lot more that we have to do here, but it's a different set of steps, right? Excuse me. It's a completely different set of steps. So don't be trying to do the polynomial steps on this. We don't have multiplicity and bouncing and crossing. We don't have that here. It's completely different. So the first step, what is first step?
Find the x-intercepts.
X-intercepts. And how do we do that?
Set it equal to 0.
Set what equal to 0?
The numerator.
Just the numerator. All you do is look at the top, set it equal to 0. And that's a pretty simple little equation, right? Just add 4 to both sides, you get x is 4. This is our only x-intercept. We should see a dot at 4. The second step, that's the second step. Vertical asymptotes.
You set that one to 0 as well to find.
Set the bottom equal to 0, right? And you solve for that, you get x is -1. That's your only vertical asymptote. So you need to understand the difference between those two things on your graph, right? The x-intercept is a point, and the vertical asymptote is that dotted barrier that forces your function up or down, all right? What's the next thing? I think this is one of the harder parts, the more confusing parts, the third part. Horizontal asymptotes. This is that magnet that pulls your graph at the ends. And remember, when it comes to horizontal asymptotes, there's 3 possibilities. There's 3 different things that can happen. So in your notes, I have this. Let me see if I can find it, because this was, I guess, kind of recent. No. Where is it? It was this day. It was 2 days before that. Come on, where are you? Here we go. So on your reference sheet, right, you might want to put this, all right, because you may need it, right? You have a horizontal asymptote, how to find them, right? So what you're going to do is you're going to look at your rational function. You have a polynomial over a polynomial. You're going to find the degree of the numerator. Let's call that n. Then you're going to find the degree of the denominator. We'll call that d. And then you compare the two numbers. If the numerator is smaller than the denominator, then one thing happens. If it's the other way, then you don't have any. And if they're equal, then you have to do this. So this is what we have right here, isn't it? This is the case we have. Let me copy this. And the problem we're doing right now, right? When we look at this, the degree of the numerator is 1, and the degree of the denominator is also 1. And according to this, if they're the same, right? If you have the same degrees, then you have to take the leading coefficient of the numerator and divide it by the leading coefficient of the denominator. In this case, the leading coefficient of the numerator is 1, and the leading coefficient of the denominator is 1. It could be 1 and 1, it could be 2 over 1, it could be 5 over 6, it doesn't matter. Whatever those two numbers are, you're going to create a fraction out of them. So you're going to say y equals 1 over 1, which is 1. This is your horizontal asymptote. Horizontal, flat like this. Dotted magnet that's at the end of the function. All right, what do we do next? What's the fourth step?
Do we start like graphing it?
Yeah, we're gonna start graphing. Let me get back to this here. I know I put the steps here. Here we go. So we found the x-intercepts. Again, this is something I would put on a reference sheet if I didn't know this. Find the x-intercepts, did it. Find the vertical asymptotes, did it. Find the horizontal asymptotes, did it. Now, plot all this information from the first 3 steps on a graph. After we do that, we're gonna do test points, and then we're gonna draw it. So let's now put all this information together on a graph. So let's say this is my graph. I'm going to start with the first thing I know. I have an x-intercept at 4. This is a dot that lives on my graph. At 4, I have a dot on my graph. Then I have a vertical asymptote at -1, which means at -1 over here, I have a vertical dotted barrier that my graph can never cross. And then the last thing is I have a horizontal asymptote at y, notice y equals 1. So think about when we talk about y, it's up and down. So y equals 1 means we need to move up 1. And do not draw a dotted line across the whole thing. I told you, only draw the dotted line out at the edges. This is going to tell you what the end of your graph is going to do. Notice how that's not the x-axis, it's up 1. Right? Everything's been moved up 1. All right, test points. Can someone tell me how to remember how many test points you're going to need? I told you there's a way to remember how many test points you're going to have.
One more than the number of
x-intercepts
that you have.
One more than the number of x-intercepts and
the number of vertical asymptotes.
Yeah, so we have one x-intercept and we have one vertical asymptote, right? So that's 2. We should have then 3 test points. So the way I'm going to look for them is I have to look, let's go on the far left. I need something to the left of this vertical. So any number I want, I'm going to pick over here, any number, I'm going to pick -2. And then I need something between this vertical and between that x-intercept, anything I can come up with between here and here. So I'm going to go with 0 because 0 is always a nice number to plug into something. And then the last number is just something to the right side of this. So you can pick 5, 6, 7, 8, 9, 10. Doesn't matter what you pick. I'm going to pick 8. I don't know why. I'm just picking 8. And what do you do with those test points?
Plug it back into the problem.
Plug it back into the function, right? So I'm going to take my function. I'm going to plug in -2, see what I get. I'm going to take my function. I'm going to plug in 0, see what I get. I'm going to plug 8 into the function, see what I get. So just take your time on this. I'm going to plug -2 into this function. So I should have -2 minus 4 over -2 plus 1. This gives me -6 over -1, and that gives me +6. And all that I care about is that it's positive, because that tells me that when I go to -2 and plug that in, I get a positive number. So something's going to come out up here. You'll see, I don't care if you put it up here at 6. It doesn't matter to me. It's just that it's above the x-axis. That's all that I care about. Now, when I plug in 0, I get 0 minus 4 over 0 plus 1. This is -4 over 1. That's -4. But again, all I care about is that it's a negative number. So here at 0, I get a point that's down here. Then I go to 8. I plug 8 in. 8 minus 4 over 8 plus 1. So I get 4 over 9. And that is a positive number. So I put it wherever doesn't matter where I put it. All right, we're ready to draw. Any questions up to this point? I'm going to start with the leftmost point that I have. That's where I'm going to start my drawing. And I'm going to draw out to the left and to the right. So as I draw to the left, I see a magnet. That magnet says I must go towards it, come to me, right? Down there. And then as I go to the right, I've got this vertical barrier that's in my way. So that forces my function up. And we talked about it in class. You can't come down, because if you come down, you're going to cross the x-axis, and you're not allowed to. You can only cross here. So then I have to pick up my pencil. I come to the next point, which is here. I'm going to draw it. Let's draw it to the right first, because to the right, I'm just connecting dots like that. But to the left, I have that barrier in my way, which forces my graph down. I cannot go up because I'll cross the x-axis. And last thing, to the right, I need to flatten out towards that dotted line, and I'm done. Questions? All right, so let's look at the next one. What I'd like to do here is, this one's harder. Okay, this is a harder problem. I just want to give everyone like maybe 5 minutes to at least do the first 2 steps. Find the x-intercepts and verticals. So set the top to 0, bottom to 0. See how it goes. We'll go for 5 minutes, see what happens. Okay, that's been about 5 minutes. Um, let's see. I kind of want to call on somebody because I always have the same people responding, which isn't bad, but I'd like to see if someone else is willing to step out and tell me what they got for one.
I got x equals 7.
Okay, so how did you do that? You doing the x-intercepts, you set the top to 0, I'm guessing, yes?
Yes. So I set the top to 0, and then I factored out an x.
Okay,
And then in the parentheses, I had 3x minus 21. And then for the first x that I factored out, I set that equal to 0. Oh, so technically there will be 2. So there will be
Okay,
0.
good, yes.
Yeah. So that I set to 0, and then I had 3x minus 21, and then just worked that out to get x by itself.
Good, and you got x is 7.
Yes.
Good. Okay, that works. Now, some of you may have done this. When you pull a GCF, you pulled an X out, you could have pulled a 3 out too, and then it would look like this. And you get the same 2 answers because you set this to 0 and you still get 0, and you set that to 0 and you get 7. So either way, you got them. Good. Okay. Someone else want to tell me about the second step, vertical asymptotes? Anyone get to that?
You would have 2 vertical asymptotes. I set the denominator to 0 and got x minus 5 and x plus 4.
And then you set those each equal to 0 and get 5 and -4.
Yes, sir.
Okay, good. So we're not showing the work here, but this is that same thing that we did before, where you take the 1, you multiply it by -20, you get -20, and then in the middle you have -1. And so your 2 numbers are -5 and +4. Okay, let's continue. Horizontal asymptotes. For that, we compare the degree of the numerator and denominator. In this problem, it happens to be the same again, right? 2 and 2. And because they're the same, what we're going to do is we're going to look at the leading coefficient of the top one and the leading coefficient of the bottom one, and we're going to create a fraction out of those, 3/1, but that's just 3. So this time our magnetic horizontal line that we're going to draw only at the edges is up 3 units, 1, 2, 3, and then out at the edges. So we're ready to put this all together on a picture. All right, I have x-intercepts of 0 and 7. So at 0, I have a point. And at 7, I have a point. I have 2 vertical asymptotes, 5 and -4. So at 5, I have a vertical barrier. And at -4, I have a vertical barrier. Then I have a horizontal asymptote of 3. So I go up 3. 1, 2, 3, here's 3, let's say. I go out to the edge and I draw a dotted line out to the edge here and draw a dotted line. There's my magnet that pulls my function towards it. Now I need test points. I'm gonna have 5 test points because I have 2 x-intercepts and 2 verticals. So that's a total of 4. So I need 1 more test point. So I'm going to pick something to the left of -4, like -5, something between -4 and 0, so like -2, something between 0 and 5, so maybe 3, and then something between 5 and 7, 6, and something to the right of 7, maybe let's say 8. So I have 1, 2, 3, 4, 5 test points. And now I plug those into my function. I'm going to do it up here. -5, 2, 3. F of -5, F of 2, F of 3, F of 6, and F of 8. So I'm not going to do each one of these. This is going to take me too long. So I'll do one of them. How about -5? I have to plug that into the original function. 3 times -5 squared minus 21 times -5 over -5 squared minus -5 minus 20. So you got to be really careful with all the signs here. There's a lot of room for error. If I square -5, I get 25, right? Negative times negative is positive. So I get 25 times 3, that's 75. And then I have -21 times -5. That's a positive number. That's positive 55. No, what is that? I can't do simple arithmetic right now. 105 over, let's see, 25 minus a -5 is +5 and minus 20. So the top is positive and the bottom is going to turn out to be positive. So positive divided by positive is positive. I have to do that for each one of these. So I know when I go to -5 and put a dot up, it's positive. Oh, I'm going to do it in blue. The blue is my graph. Any questions? Just take your time through these, all right? When you're plugging these in, you want to make sure you get these right. So I'll tell you the answers here. This will turn out to be negative. They're gonna switch. They're gonna alternate on this particular problem. But I told you in class, we have to test each one of them. So at 2, we should be down. At 3, we should be up. At 6, down. And at 8, up. Questions? Now I'm going to draw the graph. I'm not going to say anything. I'm just going to draw it and see if this is what you would get. The magnets are pulling my graph to the edges, right? Everywhere I have a barrier, I have to go up or down. I had to connect through these 3 points together and these 3 points together. Yes, no, yeah. All right, we move on. All right, now we're going to sketch some exponential functions. And this is where we finally get a little bit of relief, right? Because these don't take so much work. All this takes is a calculator. So we want to sketch this. And I told everyone to do this. I want everyone doing the same thing. And what I mean by that is I want everyone to make a t-table. And I want us to all use the same numbers. -3, -2, -1, 0, 1, 2, and 3. And so we're going to get on our calculator and we're going to go 3.25 raised to the -3, 3.25 to the -2, 3.25 to the -1, 3.25 to the 0, 3.25 to the 1, 3.25 squared, 3.25 cubed. And you're going to get those as decimals. I thought about asking this, and I might do this on the test. I might ask you, right here to sketch it, but I also may ask you, is this exponential growth or decay? So can you all tell me from just looking at this, whether or not it's growth or decay?
Growth
Growth because this number is
greater than 1.
greater than 1. If it's greater than 1, it's growth. And that means that we should know right now the graph should look something like this. That's what growth is. And that happens if the number on the bottom is bigger than 1. This thing is bigger than 1. So calculator. Okay, so let me put these in here. 3.25 raised to the -3. So I'm getting about 0.0291. I get about 0.0946. I get 0.307. Then I get 1. Then I get 3.25. I get 10.563. 34.328, something like that. So now the next important part of this, well, does anyone have any questions on that? Remember, on your test, you can use a calculator, can't use your phone. So make sure you have your calculator handy and you know how to use it. It's your responsibility to have a calculator ready to go. So when I graph this, notice I'm only drawing the top part of the graph, and that's because it's an exponential function. So I know it's going to look like that. And I'm going to put, 1, 2, 3, and then -1, -2, -3. And then I have to determine how far up I want to go. And so I can look at this over here. These are my outputs. And I can see that the biggest value I get is 34. So I need to go up to at least like 35. So maybe I can count by 5s here. So 5, 10, 15, 20, 25, 30, 35. I'm going to start with the positive ones here for 0, 1, 2, 3. So at 0, I'm at 1. Right, this is like saying when you plug in 0, you get 1. So that means I have a point right about there. Then when I plug in 1, I get 3.25. So I'm maybe about right here. And we talked about, we're just going to kind of eyeball this. At 2, I'm at 10.56. So 10 is the second dash there. So at 2, I'm a little bit above that. And then at 3, I'm way up at 34. So at 3, I'm way up here at 34, almost at 35. And so I know my graph does this and grows exponentially fast. And then over here, I told you in class that these just get smaller and smaller as you move to the left. So we have this asymptote. The graph gets closer and closer to the x-axis, right? It's like an asymptote over here. It's really hard to graph these points because they're so small and we're not being very accurate here. So it's okay if you just draw it like this and not try and put these points there. That's it. We're done. Questions? Okay, next problem is same thing, except this time, notice what the A is. Right, the A inside is 0.16. That number is less than 1. So we should expect to see here decay, not growth. Right, as you move from left to right, it gets smaller and smaller. So you can make a table again. X, 0.16 to the X. -3, -2, -1, 0, 1, 2, 3. I'm just going to crank these out on my calculator real quick. Oh, geez, is that right? That's a huge number. 244.14. $39.06. 6.25. 1.16 to the first power is itself. 0.0256. 0.004096. Oh, this is gonna suck. Okay, well, this is gonna be hard to draw. The reason it's gonna be hard to draw is because that 244. So this right here, when I plug in -3, I should get 244.14. That's way off the chart here, isn't it? So I've got to do this. So I'm going to say this is 100. Excuse me. No, that's not even going to be enough. I'm going to have to do something like this. Say that's 100. 1, 2, 3, 4. That's 200. This would be 250. This would be 50. So I'm basically counting each of those marks is like 25. All right, at -3, I'm way up at 244. I'll do it in red. Way up here at 244, I don't know, somewhere around there. At -2, I'm at about 40. So I don't know, somewhere around here. At -1, I'm at 6.25. It's going to get really hard to do. At 0, I'm at 1. And so with those dots, hopefully you can see, it's going to be hard for me to draw this. It goes like this. And then on the right, it just gets small really fast. So it's just getting closer and closer to the x-axis. This way, like that. Does that make sense, everyone? I'm going to try to make it where it's not like that. I don't want to have like any of your values go past like 50. Try and keep everything so it fits nicely. It's a little easier to draw, but this is what happened here. So, all right, we are getting close to the end here. All right, so the last two problems have to do with the formula I gave you in class, which of course I would make sure you have. It's that shampoo formula. It's simple interest, all right? That's our simple interest formula. So it says here, if you put $3,575 into a simple interest account at 3.45% interest rate, how much would you have after 5 years? Then it says, how much interest did you earn? So this number here is P. That's the amount of money we start with. This right here is R, but remember in the formula for R, you must convert it to a decimal. And the way we convert a percentage to a decimal is by taking the decimal point and moving it to the left 2 places. Don't forget to do that step. And then this right here, 5 is T, and it's measured in years. So we're going to use 5 for T. So to figure out how much would be in the account, we need to do P e to the RT. P for us is 3,575. E to the R is 0.0345 times T, which is 5. And I talked about last class how you can type all of that into your calculator at one time using that E key. So there's my, you can't see it. Yeah, you can't see that very well, but that's my typed in. Let's see what I get here. I get 4,248.07. I'm gonna stop at the second decimal place because this is money. So we can only go out to the pennies, right? And this is money, right? This is dollars. That's how much would be in the account after 5 years. So that answers the first part. Now it says, how much interest did you earn? So here we just want to know how much our money grew by. So what we're going to do is just take that number 4248.07 and subtract from it the amount that we started with. Right? So just subtract from that 3575 and you get approximately $673.07. So basically the bank paid you $673 to hold on to your money for 5 years. It's a little over $100 a year for your money. Okay, so the idea of this question, the next one, right, is I wanted you to take a look at the difference between you putting your money into the bank and having the bank pay you for your money versus you borrowing the money from the bank and you having to pay it back. So if you make a purchase for that same amount that we just had on a credit card at 17.45% interest rate, how much would you owe after 5 years? Now, this is assuming you don't make any payments. We talked about this in class. Like if you didn't make payments, they'd be coming after you, right? So same formula. This is P, this is R, but we convert it over. So 0.1745, this is still T. So the amount would be 3575 e to the 0.1745 times 5. And I'm going to pop that in my calculator and then I'm going to be disgusted by how much it is. Whoa. $8,554.57. That's the answer. Now, how much in interest have they charged you, right? They've actually, if we take that and subtract the original amount, they've charged you $4,079.57. That's the charge for it. So I talked about how do banks make money, right? If you put your money in there for 5 years, you're only going to get paid $600 for that, right? That was the previous problem. But if you borrow that money from the bank at a very high interest rate on a credit card, if you're doing like minimum payments, which means you're just barely chipping away, you're going to wind up paying a lot of money for that money. Look, you borrowed $3,500 and you owe $8,500. You're actually you're being charged more for the money than the money you borrowed, which is crazy, right? You wind up paying $4,900. That's the danger of credit cards. You can go buy a $2,000 computer, and by the time you pay it off, it costs you $5,000. So that's why it's important if you do have a credit card that try not to have a credit card, but if you do, don't do the minimum payment. I think it's law now that the credit card companies, when they send you a bill, they have to tell you, like, if you just make the minimum payment, here's how long it's going to take you, and here's how much you're going to wind up paying back, because people just didn't realize how much money they were throwing away. Okay, that's the review. Any questions? It took us just under, when you think about it, it takes about 10, 15 minutes to get started with the test. And so, it took me the full time here to do this, right? So part of this test is it's not just can you do it, but I do expect that you can complete this amount of work in the time that we have for the test, which is what, hour and 15 minutes or whatever it is. What is it, hour 15? So roughly the test is going to be about an hour after we talk and I give you the test and stuff. So within an hour, I would hope that you could do all this. So each problem is going to be equally weighted. All right. Each problem will be equally weighted. So if you, knowing that, you might want to knock out the easy, fast ones first and save the long ones for later, like the rational functions, right? Maybe you save those for the end. Just knock out all the stuff that's easy. It's totally up to you. All right, just be prepared for it. Any questions? Okay, let's call it a day then. See you on Thursday. Be ready for the test. Same as the first two exams. So everything, come, camera set up, blank paper, all that. Have a good day.
Thank you.
too.
Thank you, you too.
Thank you.
Thank you.